CWE 269, improper privilege management, refers to software flaws in which a system fails to correctly assign, validate, track, or restrict privileges, allowing an actor to gain more control than intended. Because privileges determine what actions a user or process can perform, any mismanagement in this area can undermine access control and trust boundaries. Although the weakness is abstract and language agnostic, it is critical in systems that rely on role-based access control or security context switching, such as server applications, cloud platforms, operating systems, and enterprise software. CWE 269 is a parent category encompassing related weaknesses like unnecessary privilege execution, incorrect privilege assignment, unsafe privileged actions, privilege chaining, flawed context switching, improper privilege dropping, and misuse of privileged APIs. These problems often arise from scenarios such as missing or faulty role checks, incorrect enforcement of privilege hierarchies, failed privilege de-escalation after temporary elevation, or poor internal tracking of privilege states. Examples include an API meant for admin being exposed to regular users, a mid-level admin manipulating a higher privilege account, or software that keeps elevated permissions longer than intended. Exploitation can lead to severe consequences. Attackers may escalate from low privilege to admin or root, impersonate higher level users, and access or modify sensitive data. They may also disrupt system availability or blend malicious actions into legitimate admin behavior, making detection difficulty. Preventing CWE 269 requires careful design and operations. Systems should follow the principle of least privilege, define and enforce clear role hierarchies, apply safe privilege elevation patterns, and ensure privileges are always dropped reliably. Robust auditing and logging of privilege actions help expose misuse, while focused code reviews and static analysis tools can reveal missing or incorrect access checks. Minimizing the attack surface, especially for privileged APIs, further reduce opportunities for exploitation.
An example of the potential harms that this exploit can bring about are demonstrated in CVE 2020-269-19. Originally discovered in September 2020 and patched a month later by Netgear, this exploit takes advantage of a lack of authentication checks for debug commands sent through the switch's web portal. The web portal was created with the purpose of allowing network administrators to manage the traffic that passed through the switch, and this debugging functionality was presumably added to facilitate this. However, any web page in this web portal is capable of accepting these debug commands, including the login page, which must be accessible to unauthenticated users so that the users can become authenticated. However, since the debugging system was designed with the assumption that authentication would already have been done, it only requires the post containing the debug commands to declare that it contains debug commands. Those debug commands are then run with no further checking done at elevated permissions, which would allow anyone who knows how this system works and can connect to the switch to run arbitrary shell commands at an elevated permissions level. Here we have an example of such a post which can easily be constructed by any device seeking to take advantage of this vulnerability. In February 2021, researchers observed a new variant of the Mirai botnet that took advantage of a number of vulnerabilities, including CVE 2020-269-19, to infect as many devices as possible. In all cases, the vulnerabilities are used to achieve arbitrary code execution on the vulnerable machines, and then download and run the dark binaries used by the botnet to control and propagate itself. We don't have statistics on how prolific this botnet was, however, it is prolific enough to both be picked up as a significant security threat by Palo Alto, as well as see continued development by its creators over the course of 2021, with new vulnerabilities being added as they were discovered.
After being informed of the exploit, Netgear released version 2.6.0.43 with an accompanying advisory warning. This update fixed an unauthenticated access to debug operations that Mitchell explained earlier. The exploit is still active. It's important to note that this model of the ProSafe is considered to be end of life. Those who would be exposed to the exploit now would need to have the JFS 516PE and have its software version be the one earlier than the one listed on the slide here. Netgear does not report any exploit concerns until a patch is developed. Because of this, we have a scenario where an attacker may be aware of the exploit, but the customer is uninformed. If the customer was informed prior to a patch, they may have taken some actions to mitigate their exposure, such as removing sensitive devices off the ProSafe or restricting their usage of that model. Netgear's current policy on design follows ISO 29147 and 30111, as well as CISA Secure by Design pledge. Currently, they also operate according to the European Union's Cyber Alliance Act and the United Kingdom's Product Security and Telecommunications Infrastructure Act. However, the guidelines they follow are not legally binding, being voluntary in nature. Any legal policy they follow now were put in place after the exploit was discovered, with the preceding strategies, such as the EU cybersecurity strategy, not being enforceable at the time. This implies at the time the exploit would not have been reported out of legal obligation. It's more likely a patch was applied to maintain reputation and keep customers.
We start in the backend directory. I first remove the old database, then run the server so it creates a fresh one with mock data. Next, I log in as an employee user Jade Doe. In their dashboard, they can see their requests and create new ones. The show request page lists all pending and denied requests. When creating a new request, they enter the reason, any estimated costs, the location, the date, and they upload a PDF of their receipts. After submitting, they can view the request right away, which is marked as pending. They can also download the file if they want and view all the details, including a preview of the PDF. I will now log in as an admin. The admin dashboard has one extra feature, that is the review requests. Here, the admin can see all the pending requests from employees, as well as all the past requests that have been accepted or denied. When they click a pending request, they can see the details and choose to approve or deny. I will approve one request and deny another. The status will update to approved for Jade Doe requests and denied for John Smith's requests. Now I'll show the vulnerable code. It sits in the Review API route. This route should only be accessible to managers, but the check is incorrect. It looks at the role field, which is set to EMP for every employee. Because of this, an employee can still call the Review API and approve or deny requests, which should not happen. They should only be able to create requests and view their own. When we look into the database, we see two fields related to privileges, role and is manager. Role is always set to EMP because of earlier database changes, while is manager is the correct field but isn't being checked in the code. That is the core of the vulnerability.
We're going to try and exploit our vulnerable application. Our exploit tries to mimic what an actual employee with limited experience might try to do. Right now, we're going to log in as an employee named John. You can see that John has an unapproved request which he wants to approve. The request ID is 4. We're going to change the isManager property to true and refresh to see the manager version of the website. Next, we're going to modify some HTML properties so that an approved request uses John's request ID instead of the proper request ID. And now we're going to click approve. And if we go back to the show request page, you can see that John's request has been approved. Our script does the same thing, except in Python, by interacting with a non-screen version of the Chrome browser. I'll run our script now. However, I'll have to reset the database first because we just approved John's pending request. As you can see, John's request is now pending again. Now we're going to run our script. And once again, John's request is approved.